Okay, so you got A to be your answer. A is not the answer. Okay, so sometimes a graph is helpful, and sometimes it's misleading. Okay, I purposely picked some points so that they would be close to where the circle would be. So we have to be careful. Okay, so that's why I chose what I did. So then I actually put a graph on there almost to kind of convince you should graph it. And that's fine. Let's do what she said. And you'll see there are several that are close, aren't there? And so let's look at them. So if I go ahead and look at the center of 2, -1, and you said you went up and down 5, which is exactly what she should have done. 1, 2, 3, 4, 5. We'll go right 5. We'll go left 5. And we'll go down 5. What, Sweet Pea? Yeah, and that's what's going to happen here, too. You'll see what I mean. This is just to graph it. You always go up, down, left, and right. But sometimes you're given a radius. It's not exactly vertical or horizontal. I know what you're talking about. And we're going to get there. Well, let's go ahead and just graph this guy to the best of our ability here. Ooh, how come it's not exactly working? So with that tool, so I'll just kind of sketch the graph. Well, okay, maybe I won't. Let's try again. Okay, let's do this again. Let's try this one. There we go. All right. Just because the pixels and then this, I had to change the, some resolution on my monitor here. All right, it's supposed to be a pretty circle. I know it's not, but this is going to be nuts. I'm going to try and make it perfect. I need to make it pretty. Close enough, okay? It's not perfect, I get it. But, so 4, 2, if we look at 1, 2, 3, 4, 1, 2, well, maybe not so much. But it's close. Maybe I drew it wrong. Maybe I graphed it wrong. Let's graph 2, 6. 1, 2, 1, 2, 3, 4, 5, 6. Doesn't look like so far. -2, -7. 4, 5, 6, 7. So far, nothing's hit my graph yet. And then I have 5, -5. 5. It's kind of hard to tell whether any of these are really hitting the graph. And obviously, it's because I've not done it. I've maybe not graphed it perfectly or something like that. It looks like, I'm sorry? It looks like it'll be 5, -5, and I agree with you. And it actually is that point. But I could have picked some that were even closer, and how would I really tell? So the graph is a great way to maybe eliminate some answers, but none of them exactly hit on it, right? So how would maybe I should start with an equation. Oh, I'm sorry, go ahead. I don't even have to do that, believe it or not, okay? So that's an idea. You could do the distance from, actually that is one way that would work, absolutely. I could do the distance from this point, the center, to this point, and see if it's 5. Wouldn't you agree? Wouldn't that work? And I could do 4 distance formulas? Did anybody try that? Okay, you did? And did you get, what answer did you get? So which answer was the right answer? D. D is the right answer. But yes, I absolutely agree that distance formula would be one of the possible answers, but I think there's an easier way. So let me show you the easier way that I would pick. I want to write the formula for the circle. And this is the formula. Would you agree? Okay, right? And then I'm literally just going to plug in these x's and y's and see if I get 25 out. A little bit easier than the distance formula, don't you think? Well, not if you have a calculator. So go ahead and get your calculators out, and let me show you really quickly what you can do. And that's a good estimate, but what if I gave you one that was really close but not on it? You see what I'm saying? So you have to be real careful. The graph is close, but it might not be exact. So if you plug in 4 minus 2 quantity squared plus, and then plug in your y, 2 plus 1 quantity squared, I don't get 25. So I can cross that one out. You see that? Then if you hit second entry, or second enter, you're able to go back and rewrite over top of what you've already plugged in. So now I can plug in a 2, and I can plug in a 6. You see what I'm doing? Just one and rewrote over it. Didn't get 25. And I'm just going to do that until I get the right answer. So I need to plug in a -2, so I'm going to insert a negative. So to insert, it's second delete, and I'll insert a negative. Just able to rewrite over things is all I'm doing. And it just makes it go by a little bit quicker. Second enter just lets you plug in the most, again, and you can just use your arrow key to go back over and retype things. Just so you don't have to type it in over and over and over again. It just makes it quicker for you is really all I'm doing. And then I'm going to go ahead and plug in a 5. So 5 minus 2, and then -5 plus 1 squared. And I did get 25. So that might have been a little bit of a quicker way to get the correct answer, just using the formula, okay? But yes, Julian, I 100% agree with you. Distance formula would probably, not probably, it would work too. Absolutely, okay? You're going to have a quiz on circles coming up next week. It's going to be a short quiz. It's going to cover the equations of circles. Questions like this, questions like the endpoints of the diameter, what's the equation, graph it, those kind of things will be on that quiz. And then also tangent lines and what we do today. Okay, so the quiz will be next class on what we did last time and then what we do today. Fair enough? Okay, any questions on circles or equations? Let's look at the homework answers. Here's the textbook answers first. So go ahead and look at those. And then we can go over, I think we probably need to go over, what was it, 16, 14, 12, I'm not sure. One of the ones where a lot of people didn't do them, they just drew them. Which one was those? Yeah. 12, 14, 16? Is there one specific out of that group you'd like to see? Oh, we'll get to that one in a minute. But on this one, anything from 12, 14, or 16 specifically? I said 12, 14, or 16. Anything? Do 12? Okay. And we'll also do 8. And then we'll get to VA13 in a minute, okay, sweetie? Anything else from there? This though. I graded number 18, by the way. I was really pleased to see so many of us get 78. Brittany, what you got? And 10. Okay, let's look at these 3. Fair enough? All right, let me get a textbook. I don't even have one up here. So let's start with number 8. Let me go ahead and draw the picture. You have a circle with a tangent, and we do have a radius. And I have a triangle here, where I have this is circle O, and I want to find, I want to find this angle X. Okay, good enough. All right, it's hard to tell if angle X is here or here. Was it clear to you guys? Wait, is it the corner the way I have it drawn? It's this angle over here? Okay, so let me go ahead and, so then that's probably why we got it wrong. Would you agree? So it's this angle here is angle X? It's where I had it before? All right. So this is angle X. It's hard to tell, I think, from the picture. To me, it's not very clear, but I think that's where they wanted it. All right, we're also told that this angle in the triangle is 60 degrees. I'm not sure if that's going to help us or not, but it might. I think what we're going to be looking for in this picture here is this triangle, that's supposed to be a triangle, here. And we need to find the missing other angles in it. Well, do I know any of those angles right away? Which one? Okay, so I think you're looking at a different angle. I think they're looking at this angle here. And I know that's got to be 30 because the tangent's perpendicular to the radius, right? Right, and then do I know the other angle in there? Not yet, so I've got to get some work done. So maybe I should focus on the other triangle. Okay, let's look at the little guy for a minute. Let's look at this one. I'm sorry? I don't know any other angle as X. That's the problem. I only know that one angle out there is an X. Okay? But let me finish my thought, okay? And we can go from there. If I know this angle is 60, how do I guarantee that that angle is also 60? Because it is. It's an isosceles triangle because these are both radiuses. Do you agree? Then if that's 60, then doesn't this angle also have to be 60? Doesn't really matter about that one. But if that's 60, what's its minus 180? What's this guy over here? 120. So if this is 120, how do I find the x? 180. Yes, exactly right. So 30, 120 plus x is equal to 180, and then we'll figure out what that is. And what would that be? 30? Good enough? There may or may not have been a different way to do that problem, but that's how I looked at it at first. Okay. All right, let's look at 10. All right, question 10 says, oh, we have an earth science question where you have a circle representing the Earth. We have a radius of the Earth is about 6,400 kilometers. We also are trying to find the distance to the Earth. Oop. There we go. And the distance, we're trying to find the distance, sorry. So this is 6,400 also. And it says what the h is. Oh, when h is, in number 10, h would be 1. Okay, is that correct? H would be 1. Okay, so wouldn't you just do the Pythagorean theorem here? So 6,400 squared plus d squared equals 6,401 squared. And that's where you get your answer. Do I need to continue with that one? Still need to finish it? Okay. I will. So I'm just going to quickly do 6,401 squared minus 6,400 squared, and then take the square root of that number. And it looks like about 113. Is that what they got? I don't know. Is it? Was it miles? I'm not sure. Kilometers. Okay. There we go. Better? Okay. And then the last one you guys were asking for was number 12. Okay. Number 12, this is like the one we were going to do. Remember I set it up for you before, but I didn't finish it? So why don't we just do this one together? This is a toughie. This is one that requires some algebra. Remember how we set this one up at the end of class on Monday, and I said, oh, we'll worry about it next class? Here we are. Okay. So let's set it up. What would we do? Uh-huh. Very good. Oh, no, actually, other way around. Because the hypotenuse is always across from the right angle. So it's 14 squared is equal to x plus 10 quantity squared. Okay? Just making sure we're looking at where the hypotenuse is. Okay. So this is the hard part. This is the part I told you guys we would work on today. So we can do the left-hand side pretty easy. What's 14 squared? I don't know. 196? Okay, I trust you. Then how do I multiply x plus 10 quantity squared? I'm going to have to FOIL, okay? Good. So I'm going to distribute the x times the x and the x times the 10 to give me x squared plus 10x, and then the 10 times the x and the 10 times the 10 to be 10x plus 100. And what do you think I need to do here? Combine like terms. Good. Okay. If I want to combine the x squareds, what do I need to do? Subtract x squared. And what do you notice happens when you do that? They go away. Got one on each side, they go away. We'll subtract the 196, or maybe we should go the other way. We're trying to get x on one side, the other's on the other, right? So I'm going to have 20x over here, and then we'll subtract the 100, and I'll get 96 over here. Divide by 20, 4.8, exactly. Is that what you were asked to find, by the way? Yeah, just x. This one actually worked out good. It's just remembering how to multiply that binomial out. Okay? All right, let's look at that VA13 then. These are the answers to that. I've highlighted them for you. I don't know, so some of you printed it out, make it easier for yourself. I tried to put it on School Fusion for you. But just check your answers there. You said number 2, so we'll definitely look at that one. Did I do it wrong? It's very possible. I just kind of went through and highlighted. There was no answer key. As Ms. Macker did it like within 30 seconds before y'all came to class. So I did it all right. Well, we'll do 1 and 2. Fine. I don't. Well, I knew I go through. I just did it in my head. I'll solve it for you. It'll work out. I'm pretty sure I did it right though. Maybe I didn't. I make mistakes. Anything else besides number 2? You found your mistake, Marvin? Yeah. Okay. Yeah, the scale is by 2. That threw me off too at the beginning. Yeah, the graphs were all of them actually. All of them were scaled by 2, which was weird. I'm not comfortable with that sometimes myself. Any others besides number 2? Good. All right, number 2 it is. Let's look at that sucker. Number 2. So it says the endpoints of the diameter. This is that question again, isn't it? Okay. We can graph it if we want. And actually graphing it's kind of nice because it's actually going to be a horizontal line as the diameter, so you can count to find the radius if you want. So graphing it's not a bad idea. Okay. But right now we can find the center. Okay. And how do I find the center of the circle if I'm given the endpoints of the diameter? Midpoint formula. So what's the midpoint of 6 and 6? Well, just 6, isn't it? So 6 something is the center. And then -3 plus 11 divided by 2. 4. So I can cross out these 2 as possibilities. Would you agree? Now it's a matter of figuring out what the radius is. The radius is going to be the distance from the center to an endpoint. Well, since it's a horizontal line, I can just count from 11 to 4, right? And that's 7. 7 squared is 49. So that's why the answer is F. Again, a graph might help you there if you need to. But that one didn't require a distance formula like the one we did in class. That one you could have counted. Okay? Not bad. All right, we are going to, we already did a problem like that. We're going to look at a problem like this. And I've already printed it out for you. Because I thought to myself as I made this up, this is a lot of writing. So I wanted to create it for you already. And you kind of just fill it in as we go along. And this is just some vocabulary. How do I name parts of circles? What is the secant? How do I name it? What is a chord? What's an arc? A major arc, a minor arc, I don't even know. All these different things I have listed on here. I'm going to add a few. I have central angle on here. Good. There's a sector of a circle is another piece of vocabulary we might add to it. Everybody get one? All right. So really this is just kind of you filling out stuff at this point. Okay, so I want you to kind of fill it in as we go along. And let's look at what we can add to this picture in terms of the names of some things. So in the top left-hand side, the name of the circle. How do I name a circle?
By the center.
By the center. So this would be called circle what? A. So that's what you're going to write. And the notation that we would use would literally be circle A. Okay, that's the notation that you would use. Circle with a dot in the middle. Okay, that means circle A. Did you get one?
Yes.
She's writing for you because she's a nice person. Thank you. All right. And yeah, you can print these off too at home, which will be good for you. All right, so there are lots of possible answers here. I want you to take a minute. I'm going to pause the recording. I want you to take a minute and talk with your group members and decide which of these are radiuses, which of them are diameters, chords, secants, tangents, and leave blank what you're not sure. And make sure you're using pencil in case we need to erase. But I want you to try these for just a couple minutes first. So I'm going to pause the recording. I want you guys to talk to the people at your table. Make sure that you're comparing your answers, okay? I'd like to add one piece, a couple of extra definitions for you. I'd like for you to add the words inscribed angle I'd like for you to also add a sector. So we have all the definitions that we could possibly need, okay? So if you kindly add those two for me as you're filling these out. Sure. All right, let's go ahead and see how far we got. There, again, are multiple answers, so it's okay to just list one, or if you wanted to list all of them, that would be great too. But give me one of the radii. Eric, what'd you find for a radius? DA, I agree. And the notation should be segment DA, right? Or AD, either way. Anyone get a different answer? What'd you get, Gabriel? AI or IA, segment AI. Anything else? Go ahead, Emma. AL, is there another one? Lucia? AK, is there another one? I think it's just those four, right? All right. How about a diameter? What'd you get for that one? Daniela, what'd you get? DI, very good. It is segment DI, so make sure that we're using the correct notation. I agree. How about a chord? There's multiple answers here. What'd you get for that one? Try, Julia? JK. I love that. JK. I don't see where K is. Hang on. Oh, that's why I don't see it. Yes, JK is a chord. I agree. There are lots of chords in this picture. Anyone get a different one? What'd you get for me, Deshay? JL is also a chord. What else did you get? Anything else? Say it louder. MN. Yep, M is down here. You don't see it, but MN is also a chord. I agree. Anything else? DI is another chord. I agree. A diameter is also a chord. Lots of answers there. Good. All right, how about a secant? I actually think there's only one. No, there's two. I'm a liar. Tashay, give me a secant. CH. And you want to say line CH, right? Because a secant actually passes through, so we would have to use the line notation. You see the other one, Amira? Line BE. That's exactly right. That's the other one. Okay? Excellent. All right, I think there's only one tangent line. Anyone want to venture? Reese, you want to venture to see what the tangent line is? OD. I agree. Could you have said OE? Because E's on the circle. E is not on the tangent line. Okay, be careful with that. It is a line in this case, OD, but because that's a good question, because you can have tangent segments also, right? It's the secants that are required to be lines. It could be. Central angle. All right, Deshay, hit us up. LAK, and since we're using an angle, we're going to go ahead and say LAK, and I agree. That means if it's a central angle that the vertex is the center. It's that easy, okay? I'm going to highlight it here because we're going to talk in the second half of class about central angles versus inscribed angles, but that is a central angle, and I'm going to use a different color to highlight an inscribed angle. Anyone want to care to venture which one the inscribed angle would be? India, help us out. All right? No. Brittany? KJ, let's look. KJL, look at you. Must be the QP. I love it. Okay, KJL. Inscribed angles, where's the vertex? On the circle itself, okay? So central angles, the vertex is the center, and inscribed angles, it's kind of like you pull it back. Has the same endpoints in this case, doesn't it? But you pull it back. That has to do with the measures as well. Notice that the arc that they intercept is the same. Do you see that? That's called an arc. That would be an example of a minor arc, by the way. And the notation that's used for that would be KL with a little arc on the top. Okay, I can't really see that little arc. Let me try it again. Right a little bit lower. A minor arc would be KL, like that, with a little arc on the top. There are lots of arcs. ML, HI, DE, DM, KE. I mean, there's lots. Minor arc, what's the difference between a minor arc and a major arc, do you think? Suman, you haven't answered the question yet. What do you think? What makes a minor arc minor and a major one major? It's bigger, and specifically it has to be bigger than one thing. What do you think it has to be bigger than in order for it to be a major arc? Yeah, bigger than half. That's exactly right. So bigger than 180 degrees. So can you think of a major arc in this picture? B to what? Well, that's a question. Which way do we go? It doesn't matter, actually, with this, believe it or not. Okay, we're not assuming the degree measure. How we name a major arc, though, is we use 3 letters. Okay, because if you, for example, if I just said KL, we know that's a minor arc. But what if I said K, how would I describe the other arc going the other direction? In other words, how would I describe, hang on, I'm going. It's too big of a picture. How would I describe that arc? It still has endpoints KL, but I would say KML, KEL, KDL, KOL. I don't care. Pick one of the other points along the middle. Does that make sense? Any of the other middle points would work. Well, it would start with K, right? It has to start with K. So KML, that would work. It could be KEL. It could be KIL, KHL. As long as it ends with K and L and then some other point is in the middle, it describes that major arc. Okay? So I'm just going to say KDL. And that would represent the minor arc, the major arc, sorry. 3 letters. Yeah, you sure do. How about a semicircle? All right? Well, give me, there's two of them. Which one are you talking about? It also has to have 3. Now, what if she just said DI? Why is the third one important? Well, DI, well, even if I had the arc across the top. Right, because the letter in the middle tells me whether I'm talking about the top of the circle or the bottom of the circle. They are the same. I agree. We're not talking about length yet. We are going to get to arc length in a couple class periods. But it kind of does, because what if we're talking about something else and there's an angle up there? So we would use, and I agree, the lengths are the same, but it's not always about the length. So we're just naming it. What did you say, honey? DKI. Okay, that would work. Yep. I agree. Okay. So we've already done the inscribed angle. Which one did we say? KJL. So the last thing is a sector. What's a sector? You know what a sector is, Julian? Oh, sure. Well, a semicircle wouldn't be major because it's exactly 180 degrees. It just has 3 letters. But the endpoints would be on the diameter. Okay? Let's go back to the question of a sector, though. What is it? A lot of you eat them a lot. Pizza, a slice of pizza would be a sector. I love pizza. Don't you love pizza? Now I'm hungry. Just kidding. Yes. Kind of, yes. So it's the central angle, but it's not just the angle. It actually includes this little piece down here. So a sector is actually this whole, well, I shouldn't do that color. Let's do the yellow. Is this whole thing would be considered the sector. So it does, I agree with you, start at the center, but the sector is it's like we're going to find area of sectors. So it's actually like the whole slice, okay, including the rounded tip. It's not like a triangle. It's like it's a rounded. It's called it's a slice of the circle. Think of a slice of pizza. I'm not really sure how we name it other than by its central angle. We would say the word sector, KAL. Okay, that's how you would write it. So you would say, you can say sec if you want, sect if you want, sector, KAL, sorry. Okay, that's fine. Just some basic notation, just some basic, do you know these definitions? I'm never going to ask you to repeat the definitions, but I'm going to refer to them all the time. So I just want to make sure that you're using the correct notation. You should have learned this before, but maybe you did, maybe you didn't. I don't know. So let's use our information. We're going to talk specifically about two things today. We're going to talk about chords, and we're going to talk about inscribed and central angles. And we're going to start with the chords. We know what a chord is. So let's ask a sometimes, always, never situation. You don't have to write this down. Let's just kind of go through it. And let's look at number one. Amira, what do you think? A chord is what a diameter? Sometimes, always, or never? Late and diagonal slate? I'm sorry, sweetheart, what? Sometimes? What do you think? I agree, sometimes it is. What if it went the other way around? A diameter is blank a chord. That's your always one, right? All right, a radius is a chord. Never. A chord has a related arc. What do you think that means? So that's a chord up there. There's a chord up that's drawn up there. Is there an arc that's related to it? What do you think? What do you think they mean by that? Well, they mean that the endpoints of the chord kind of cut off and make an arc. And so arc RS is the arc that's related to chord RS. That's all they mean. Yeah, so always, yes. And that's important because we're going to learn a couple of things here in a minute well, I'll tell you in a minute about the chords and their arcs. A chord has a related arc always. An arc is blank a semicircle sometimes. All right, so we know this stuff. Good. We've got our definition set. Do not write all this down before you say, you've got to write a couple of them down, but not all these things. Yes, love? Why was it sometimes? Because an arc, sometimes it's a semicircle, sometimes it's a minor arc, sometimes it's a major arc. Okay? All right, so do not write, there's four or five, there's 1, 2, 3, there's 3. All right. Don't write all this down. I will tell you what I want you to write down. I like the picture of it, but it's a lot at one time. So let's just kind of go through one at a time here. Okay? So let's start with just this. Look at the picture. Don't write it down. Just look at the picture. And I want us to decide that in order for arc AB to be congruent to arc CD, the arcs now, what angles would have to be congruent? The central angles, right? If the central angles are congruent, then the arcs are congruent. Kind of makes sense, doesn't it? That just kind of is almost natural to say. So what was that? COD? You can print this off at home if you'd like it for your notes, but it's almost common sense, so I don't think we need to write it down in our notes, okay? If the angles are congruent, then their arcs are congruent, as long as they're central angles, okay? And vice versa, the converse of that is also true, okay? If the angles are congruent, then the arcs are congruent. All right, here's the second one. If angle AOB and COD are congruent, so if these angles are congruent, then what must AB, the segment now, not the arc, but segment AB, what must it be congruent to? Segment CD. Again, common sense, don't you think? Nothing really unusual yet. All right. And then the last one is, in order for these arcs to be congruent, so AB and CD are congruent, what segments must be congruent? AB must be congruent to CD. I mean, it's like nothing really hard. Basically, when you have a chord like this, RS, and it cuts off that arc, and I have another chord over here that's the same length, then we'll call this QT. Okay? Then isn't arc QT the same length as arc RS? Yes, it is. If the chords are congruent, then the arcs should be congruent. That's what that theorem just said.
Oh, I see what you mean.
Just the chords and then the arcs, right? That's all it is. Right. So again, nothing too unusual, but let's use this idea. Okay? So read the problem. Don't write it down because this is, again, I think this is too basic. I just want to kind of just go through it because it almost is too much common sense. We're told we have two congruent circles. Circle O and circle P. I'm also given a couple of congruent angles. Joshua. Do I need to make you stand, honey? Would that keep you awake? You have some advice over here.
Yeah, Josh. Go on a walk.
You want to sit in the big chair? Would that make you more comfortable? Right, that'd be terrible. How can I show angle O is congruent to angle P? If OBC is congruent to PDF, if the circles are congruent, what can I notice? What kind of triangles do I have inscribed in both of those circles? Why are they, don't tell me, Marvin, I know you know. Sharia, why are they isosceles triangles? Because the radiuses are the same. Perfect. So if that's true, aren't these two angles also the same? Because aren't the base angles of an isosceles triangle congruent? So then why are O and P congruent? Question first. No. There are proofs in the book with this, but we're not going to do those, and maybe after the SOL. We'll see. Okay? O and P. Why are they congruent? Because the triangles, all the angles of a triangle add up to be 180, and so the remaining triangle would have to be, the remaining angle is also congruent. Big thing out of this one is if you have a circle with a central angle, those are congruent. Always going to be an isosceles triangle. Something to look for, okay? You'll see that quite a bit. All right, again, don't write this down, okay? But I do want us to do one of these one at a time. Let's see if this is something that would be unusual. Actually, this is one to write down. Sorry, this is one. Sorry, just this one. So write this guy down, okay, and draw the picture that goes with it. This is the one thing that you should probably write down. It's not quite so common sense. If you have a circle, or you have two congruent circles, either way, but in its own circle, that makes sense. We have some chords in our picture. We have chord AB and chord CD. And it says equidistant from the center. So that, to me, I need to know why the picture's drawn that way. How do I know, based on my picture, that the chords are equidistant from the center? That's exactly right. Okay? I think that's kind of awesome that you know that, quite frankly. If they are equidistant from the center, those 90-degree angles is what it says that. The word equidistant means these 90-degree angles here. They're the same distance to the center. Okay, the shortest distance is a perpendicular line. Okay, so what is that theorem actually saying? If the chords are equidistant to the center, what do I know is true about the chords themselves? The chords themselves are going to be congruent. Okay? So if I know this to be true, then I do know for certain that length AB is the same as length what? CD. Very good. Okay? I didn't even look like a C and a D. Try that again. I know that for certain. Okay, so that's an important one. So draw the picture with that, okay? And make sure that you have this statement written down, okay? Good. All right, let's look at the next theorem. Let's see if we need to write it down. Yeah, probably need to write this one down too, okay? So we're going to write two of these and look at its picture. So another case, in a circle, if a diameter is perpendicular to a chord, that could be a radius as well, okay? It doesn't have to be a diameter, but it has to hit the center. Then it bisects the chord, and it bisects the arc too. So that's what's drawn up there, okay? I'm given what's in red. I'm given that AB is perpendicular to CD. Therefore, CE is congruent to ED. And CA, arc CA is congruent to arc AD. Okay? Any diameter perpendicular to a chord cuts it in half. Okay? You can visualize that. I can see that. And we're going to use that information. Okay? So you've got two things really that I need to pay attention to with chords. If they're equidistant to the center, they're congruent. And if they're perpendicular to a diameter, then it's bisected. Okay? That makes sense. So let's try to look at some examples with these two theorems. Okay? You guys got a copy down? I'll wait just a second then. Let's go ahead and look at an example. Okay, so here's an example. We want to find the length of, the value of x. Don't copy this example down. You can look at it. There's no work to be done. Just look at it. What's the length of x? How'd you know that? Because if they're equidistant from the center, right? If the chords are congruent, which they are, we have 18 plus 18 is 36, right? I have two congruent chords, therefore they must be equidistant from the center. So x is 16. Duh, right? That's like, makes sense, right? We got that. All right. Let's try another one. This one is probably one you should copy down. This one's a little bit more, you can't just look at it and get an answer. It's a little bit more involved. I want to solve for y. And I'm actually going to cover up some of the problem because I don't want you to see how to solve it. I just want this to be here. And I want to tell you to solve for y. As you're copying this problem down, I want you to recognize that I most likely would not draw the dotted line in for you. But I'm telling you it should be there. So that's something you'll need to be able to do on your own when you do a homework or on the quiz that you're going to take next class. That dotted line may or may not be there. Okay? So what information are we actually given? What is in the picture that's labeled? What's 15? Use a circle word. It's a radius. Okay? What's 11? It's part of a chord, right? Half a chord. The whole chord's 22. Would you agree? Okay. What else do you notice in the picture that we could add to it? There's a 90-degree angle somewhere. I agree. And the only reason why I know it's a 90-degree angle somewhere is because I have a bisected chord. Do you see that? And when the chord is bisected, if I were to extend this, wouldn't it be a radius if I went all the way through, or diameter or whatever? Goes to the center. So I know that this angle here is a right angle. So you want to add that to your picture. It is. It's perpendicular. Why is they call it the auxiliary line? The auxiliary line BA, or segment BA. Why is the dotted line important? Why do I have to have it? Julian? What kind of a triangle does it form? There you go. I will tell you that with circles, you will use right triangles a lot. They show up everywhere. Here's an example of that, okay? So this angle, or this triangle right here, is a right triangle, okay? And we're going to use what we know about right triangles. What's the length of the dotted line? Because it's also what? A radius. So I know that it's 15 as well. So how would I find y? Pythagorean theorem. Good, Emily. Exactly. So I'm going to say that 11 squared plus y squared is equal to 15 squared. Awesome. That's exactly what I'm going to do. So go ahead and use your calculators and tell me what the length of y is. So let's make it radical form. How do I reduce the square root of 104? Did I skip too many steps by getting 104? Are we okay with where the 104 came from? Anybody need help with that? I put it up on the calculator if that helps you. How do I reduce 104? How should I start that? It's not an exact answer, by the way. It's not a perfect square root. Little factor tree. Give me two numbers that go into 104. 8 and 13, right? Yeah. 13's prime, right? So we can't do that any further, so we'll just continue with that sucker. What about 8? I'm sorry? 4 and 2, okay. 2's prime, so we'll continue it along the path, and then we have 2 and 2. So what comes out? A 2. What stays underneath? 2 times the 13, which is 26. So that would be the reduced radical form. Yes, love? Multiply. Multiply. Mm-hmm. Yes. Okay. Feel good so far? It's not hard, right? It almost kind of makes sense. It's just looking for being able to move that radius over to make the right triangle. Fair enough. All right, we're going to kind of switch gears for a little bit. That's all we have with chords, so don't write any of this down yet. This is really basic, easy stuff. We're going to talk about central angles now, the central and the inscribed angles. Just really quickly, what's the measure of x, angle x? If the arc measure is 32 degrees, what's its angle measure going to be? 32 degrees, okay? So arcs have measurements, like 32 degrees is part of the entire 360. So those arcs have degree measures as well. But the angle measure is the same as well. How about down here? What's arc measure x? How'd you get that? So this is a diameter, and I have this arc measure as the same. They should all add up to 180, so this arc measure should be 55. Like, this is just we're okay with this. Nothing too difficult. When we get to, oh, wrong thing. When we get to inscribed angles, okay, this is the wrong page. I made something wrong. Inscribed angles, we already know what it is. Let me draw it on the other page. Hang on. Let's do it here. Let's draw here. The inscribed angle would look something like this. Would you agree with that? And what if I called that and I said, this is the measure y? We know x is 32, but what about y? Does it look like it would be smaller or bigger or the same? Kind of hard to see the way that picture's drawn. Maybe if I draw it on a bigger scale. Let me try that. Okay, so let me draw a bigger one. Oh, well, that was supposed to be a dot for the center. Let's draw a fairly large central angle. Let's say that that's 85 degrees. And I want it to intercept the same arc, so I'm just going to make those dots here. And then I'm just going to kind of imagine those being thumbtacked down, and this is like a rubber band. And I'm going to take this angle by the vertex, and I'm going to pull it back. A little easier to see whether it's bigger or smaller or the same now. It's going to be smaller. Quite a bit smaller. It's exactly half. Okay? So an inscribed angle is going to be half of its arc. So if that's 85, what's the angle going to be that's that's half of that? 42.5? Would you agree with that? Half of it. Okay? So inscribed angles have half of the measure of their arcs. And again, the intercepted arc is this guy right here. Would you agree? Okay? All right. So let's look at 3 problems. And I do want you to write the 3 problems down. I do want you to copy all 3 of them. They're down here. And we're going to look at finding the measures of lengths x and y. So I'll pause it for a minute while you copy them down, okay? And a y. What do you think about the first one? That's a basic one. Multiply by 2. So what did you get, Gabriel? So x is 64 degrees. Would you agree with that? I think sometimes it's a little hard to make sure. And once a picture gets more and more complicated, it's going to be important for you to be able to make sure you're looking at the correct arc, okay? These are very basic questions, but sometimes the pictures, like, I mean, honestly, if you looked at this picture I gave you in your printout and I put degree measures and things, it would be a little bit more difficult to see, right? So you might want to think about, I have an erasable highlighter that helps me, where I can highlight something and then erase it and that kind of thing. So just food for thought. But I agree. X is 64 degrees. Excellent. All right. What do you think about number 2? What's 80? X or Y? Nope. Close. Close. Okay, we do know Y is 100. Let's make sure everyone can visualize that, though. Y is the arc. When it's on the outside of the circle, we'll assume it to be the arc, okay? So that's a good question. So right here, we're going to say that Y is the length of this, okay? Notice what it does with angle 50. Isn't that the intercepted arc for angle 50? Right? It's the inscribed angle, and it intercepts that blue arc. If the angle is 50, what does Y have to be? 100. Okay, so Y is 100. Good. X a little harder to see, which is again why an erasable highlighter sometimes is good here, because I'm going to erase what I highlighted. And I'm going to go back and re-highlight now angle X. What arc does that intercept? Well, this one intercepts that arc. What's the length of that arc? No. It's a semicircle. It's 180, right? Semicircle, right? That diameter cuts half a circle. We know that's 180. So what's the measure of X? 90. So you were close, okay? 90 degrees. So again, it might be easy if you highlight and erase them, or darken and erase if you're going to use a pencil, just so you can really see the angle versus the arc that it intercepts. It's a good visual there. All right, so do the same thing here with X. Here is angle X. Here's going to be the arc that it intercepts, which is 126. So what's the measure of X? 63? 63? What about Y? It is exactly the same, because angle Y intercepts the same arc, doesn't it? It's kind of like, you could think about this, if these were thumbtacked down here, and I took the vertex and I slid it around on the circle, wouldn't that angle be the same no matter where I drew it? It'd be the same no matter what, as long as it was thumbtacked here and here, and the arc the arc it intercepted didn't change.
What if you move it towards where you want to be?
Nope, as long as I brought it close to it, as long as I was on the other side of it, it wouldn't change.
No matter where.
On the other part of the arc, okay? Not the 126 part, but the other part of the circle. Good question. How do we feel? That's it. It's not bad, right? So let me go ahead and tell you what your homework is. I'm going to let you guys start it now if you want, so you don't have to worry about it too much. You're going to have a little bit of both. Like I said, you are going to have a quiz next class, and the quiz is going to be on everything we've done so far with circles, okay? Equations of circles, tangent lines, chords, and then now the central angles and inscribed angles. So let me tell you what your homework is. It's in chapter 12. Can y'all believe we only have 1.5 more units to go and we're done? Kind of crazy. All right, we're going to do page, I don't even want to say that, but yeah. So we're going to do there's two pages you're going to do, okay? So 776 to 777. I'm going to have you guys do 6 through 15 all. You don't need to draw the pictures because they're in the book, okay? But if it helps you to draw the pictures, that's fine. And then the inscribed angles on page 784. I'm going to have you do the even ones here. 6 through 18 even. So you don't have too much homework, okay? But again, quiz next class as well, okay? If you want to grab a book, feel free to go ahead and grab a book and you guys can get started. You've got about 15 minutes, okay?